Hello everyone. Our today's topic is the clipper circuit, okay, or how a diode will act as a clipper circuit, okay. Here you can see I connect a voltage source, AC voltage source, and in the voltage source I connect a 10 volt AC voltage source, okay. So if I just simulate this circuit, you can see the input voltage is plus minus 10 volt AC, okay. This is a sine wave. So if I check the output voltage, you can see that the output voltage is clipped at the positive half cycle, right? And that clipping is around 1.7 volt, right? After 1.7 volt, you can see it's clipped, right? There is no positive half cycle. Okay, after the 1.7 volt, there is no output voltage. It's just flat, right? So why that is 1.7 volt? As you can see here, this diode is a practical diode. That means the voltage drop across this diode is 0.7 volt. And you can see here, this voltage source is 1 volt. That means the cumulatively, these two will act as a 1.7 volt voltage source. Okay. So I can control the clipping of this voltage source by changing the voltage of this DC voltage source. Okay. So if I increase this one to 2 volt, you can see that one is just increased to 2.7 volt, right? And if I increase this to 0 volt, you can see it's very close to 0, right? And if I increase this to 4 volt, you can see that one is clipping a little bit, right? 4.89 volt, right? Suppose if I make it as a 5 volt, you can see that there is no clipping, right? We can get the full sine wave, but the magnitude is half. Why half? You can see this is 1 kilo ohm and this is 1 kilo ohm, right? That means this voltage will divide it in this particular two resistance, and according to the voltage division rule, if our input voltage is 10 volt, then the output voltage will be how much? The output voltage is plus minus 5 volt. Okay. So this is the basic concept of the clipper circuit. Okay. What if I just delete the resistance? You can see that I just disconnect the resistance, right? And here is the 5 volt. And this is the 0.7 volt, right? And in the input we have 10 volt. So now you can see that our clipping will be after 5.7 volt. You can see it is after 5.7 volt, right? And now if I increase this one to 10 volt or 20 volt, now you can see we directly got the input voltage in the output. As I increase the DC voltage to 20 volt, right? That means the voltage needed to turn on this diode will be 20.7 volt at least, but our input voltage is 10 volt, so it will not clip. Okay, so we will just get the output voltage. So if I increase this input voltage to 30 volt, you can see that there will be again clip, right? And the clipping is around 20.7 volt. Okay, so this is the basic concept of the clipper circuit. Clipping means when the diode will be turned on, at that time current will flow through the diode, okay, and the clipping, you can see the clipping, okay. As when the diode will be turned on, at that time output voltage will be constant, okay. So that's why we can see the clipping, okay. So what if I just delete the voltage source and directly connect the diode? What you can see? You can see that there will be no positive half cycle. This will be act as a negative half wave rectifier, right? This will also a clipper circuit. This will clip the entirely positive half cycle, okay? And if I change the direction of the diode, then what will happen? Then it will clip the negative half cycle. You can see that it will act as a positive half wave rectifier. So this is the basic concept of the clipping circuit. Now let's go to the theory and I will explain you how a clipper circuit will clip the input voltage waveform. So now we need to understand why that particular circuit work as a clipper. Before that, you need to know the basic concept of diode, okay? This is the diode where this is P and this is N, okay? And current will always flow from P to N direction, okay. And if this is a practical diode, when the diode will turn on, at that time it will work as a short circuit, okay. And when the diode is ideal diode, at that time it will act as a voltage source, okay. That means if a diode will like this, then when it will turn on, it will be like this 0.7 volt voltage source. Okay. And one more thing is, if this is V1, this is V2, we know that if we need to connect this diode with a forward bias, then V1 minus V2 greater than equal to 0.7 volt for the practical diode, and for the ideal diode V1 should be greater than V2. Okay, here we are considering this one as a practical diode, right? That means V1 minus V2 greater than 0.7 volt, right? Here this one is around 5 volt. Okay, if this voltage source is 5 volt, that means V2, this point is V2, right? So this point is V2 will be equal to 5 volt, right? And this point is V1, right? And this diode will be turned on when V1 should be greater than 5.7 volt. Why? As V1 minus V2 should be greater than 0.7 volt. Here in this circuit, V2 is 5 volt, right? That means V1 should be greater than 5.7 volt such that this diode D1 will be on. Okay, when V1 will be less than 5.7 volt, at that time D1 will be off. Okay, so first case 1. Case 1 is V1 is less than 5.7 volt. That means in the sine wave, this is sine wave, right? The sine wave, suppose this is 5.7, right? Suppose this is 5.7. Okay, so we will talk about this particular time period when the input voltage is less than 5.7 volt. Okay, so now we are dealing with this particular time. Okay, when the input voltage will be less than 5.7 volt. Okay, now if V1 is less than 5.7 volt, that means this diode will be turned off. Okay, when the diode is turned off, at that time, whether this is a practical diode or the ideal diode, it will act as a open circuit. So the circuit will be looks like this one, right? And we all know that the resistance of the voltmeter is infinite, right? That means no current will flow through this particular circuit, as here we have the open circuit as the diode is open. Okay, and we have a voltmeter, right? That means this circuit is a open circuit, right? That means there will be no current flow through this particular circuit. Okay, so we will get in the output will be the same as input voltage. Okay, so if suppose this is 5.7 volt, in the output we will get the same voltage as the input. Okay, this is the case 1. Now let's go to the case 2. Case 2 mean when the voltage V1 should be greater than 5.7 volt. That means we are talking about, if this is a sine wave and this is a 5.7 volt, then we are talking about this particular time when the input voltage is greater than 5.7 volt. Okay, and for this time we already get output will be same as the input, right? Now when the diode is turned on, at that time it will act as a voltage source, right, of 0.7 volt. So how the circuit will looks like? The circuit will be like this, 1K, and this is a voltage source, another voltage source. So this voltage is 0.7, this is 5, right? And we have a voltmeter. So here you can see that this voltage source is plus minus, this is plus, this is minus, right? That means the two voltage source connected at a series, right? That means it will add together, okay? And the voltage we will get is the 5.7 volt. As this is a constant voltage, this is a constant voltage, as this one is not depend upon the input anymore, as input Vi is greater than 5.7 volt. That means we will get a constant voltage when Vi will be greater than 5.7 volt. That means this will be constant up to this line, and then again it will be follow the input, right? As Vi will be less than 5.7. Okay, and in the negative half cycle, still V1 is less than 5.7 volt, right? As this is a negative, that means we will get the same as the input voltage. Okay, now you can understand why we get this particular waveform in the simulation output. Okay, now go to the another problem where I just connect a resistance at the output. This is 1 kilo ohm resistance, and we have the same 10 volt voltage source, and this is the diode D1, right? We have the same situation. This is V1 and this is V2, right? When V1 is greater than 5.7 volt, at that time D1 will be on. Okay, and V1 is less than 5.7 volt, at that time D1 will be off, right? But for this particular circuit, you can see here we have 1 kilo ohm resistance and 1 kilo ohm resistance, right? That means in the sine wave, the peak voltage is 10 volt, right? If we consider this one as a 10 volt, then this will be divided in this resistance and this resistance, right? That means we will get maximum of 5 volt across this resistance. That means V1 can be maximum 5 volt, right? V1 cannot be greater than 5.7 volt. That means for this particular circuit, it will not act as a clipper circuit. Why? For all of this time, this diode D1 is off as V1 can be maximum 5 volt. So the output will follow the input voltage, but the magnitude will be plus 5 volt here, minus 5 volt. Okay. But if I give this one to the 20 volt, then we will get the clipping. Why? Then if this is 20 volt, that means the maximum V1 can be 10 volt, right? That means it will match our condition, V1 greater than 5.7 volt. If we need V1 as 5.7 volt, then the voltage, input voltage should be Vi will be 5.7 multiplied by 2. It will be around 11.4 volt. Okay, if we give 11.4 volt, then these two resistance divide the voltage and V1 will be 5.7 volt, right? That means up to 11.4 volt, the diode will be turned off. Okay, and this will be 5.7 volt and this will be 11.4 volt. Okay, after that one, what will happen? It will be kept constant and then it will again drop. Okay, and the second negative half cycle will be the same, but the maximum output voltage we can get is the minus 10 volt. Okay, so when you have the resistance in the clipper circuit, at that time you need to remember, if this is R2, this is R1, you need to remember that always VR2 or V1 will be R2 by R1 plus R2 input V into V input. Okay, you need to remember this particular equation for the voltage calculation. Okay, if there is no resistance, at that time you don't need to consider this formula. Input voltage will be same as V1. Okay, as there is no resistance. But when there is a resistance, at that time you have to consider this formula. Okay, so now I think you understand in the simulation why that circuit behave like the clipper circuit. Okay, so that's all for this video. See you in the next video. Thanks for your time. Please do share this concept with your friends, and if you like this video, please press the like button. It is really means a lot for me. Bye bye.